Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Ben Watson. He's a principal software engineer working on Bing. How are you, sir?
I'm doing great. Thanks for having me.
So Bing is pretty big, I'm assuming, right? Like, how big is this thing and how is it layered?
It is fairly large. I think, if you talk to any one person, they're probably in charge of only a small aspect of it, but there are many layers. You've got a UX layer. You have a federation routing layer, which is the part that I work on. And then you've got just innumerable back-end layers of data repositories and databases and different layers of business logic. And, you have the whole web index and lots of other things.
Mm-hmm. So when I go in Bing for something, I type it Bing and I hit enter. The UX layer handled that. There's probably some front end engineers at some point, and then that's your front end. I hit enter, and then what happens?
Yeah. So if you go to bing.com and you type in a query, so as you're typing, it's going to be auto-completing some suggested queries for you. So that is a workflow that is going from the front end to the federation layer, this workflow engine that I work on. And then if you hit enter at the end of your query, it's going to send your final query on another workflow. That I guess we consider that our main workflow. And we will process, that query, federate it out to, thousands of individual components. We call them plugins. Some of those are running on, the machine that the query hit. Others are sending IO requests to various backends. And, rinse and repeat, do this a few thousand times. You have responses to a query. It gets ranked. We send it back, and the UX layer will render it.
Mm-hmm. So a lot of those plugins get a chance to vote about stuff. Like, hey, I know that was an address, or that was someone's name, or I know more about that, right?
Yeah. So there's a classification layer that runs, so you can tell what kind of query this is, and that will help select which areas of this workflow to run, shut off other areas. So yeah, the whole workflow, if you looked at it, just statically, it's huge. Hundreds of thousands of nodes. But in any given query, only a fraction of those are going to run just based on what kind of query it is.
Okay. And then the central workflow engine, the part that you work on, is that called ZAP? Is that like an internal code name?
Yeah, it's our internal name. I don't know if I'd call it a code name. It's a name steeped in lore and mystery dating back, I think, over a decade. But it nominally stands for, or at least used to, extensible application platform. And I think that's still true. The intent behind that is still true. I think most people just call us ZAP, and it's just kind of stuck. But yeah, we are the workflow engine. So we sit right between the UX and all of the various backends. And, our job is to execute the query as quickly as possible.
Mm-hmm. And now for many years, that was running on .NET Framework. That would be .NET 4, .NET 4 something.
Yeah, it was actually a C++ product back when I started, much smaller in scope. I think this was before Bing was even Bing. It was Live Search, if anybody remembers that. But a couple years after I started, we did a huge migration to .NET Framework. I think we went to 4.0 first. That, I believe we migrated to 4.0. There might have been some 3.5 in there, but I think we're mostly past that. So 4.0, then 4.5, and I think then eventually we settled on 4.7.2. I'm not sure we actually made it to 4.8 before just moving to .NET Core.
Okay, so I love that you said just moving to .NET Core.
Yeah, just moving. just 2 years of effort to move to .NET Core.
Okay, so let's talk about that because, I'm out there talking to people about how moving to .NET Core is a good thing. Now we call it .NET 5, .NET 6, .NET 7, and 8. Mm-hmm. So there's no core anymore. Why is that, or why was that a 2-year thing when I'm out there, Hanselman's out there saying, oh, it's easy? Because it's not easy,
It's all easy, depending on your scale or your scope or how much influence you have over the organization. For us, it was largely a matter of dependencies as well as just our architecture. We we develop very disconnected from our partners. So we provide a platform for hundreds, if not thousands, of other developers at Microsoft to build pieces of the Bing experience. And by the way, I want to mention it's not just Bing.com that we're powering. We also power other search experiences in Windows, in Office, in Substrate, other things like that. Anything that needs a fast, high performance workflow engine, often it is going through us in Microsoft. So not just Bing, but Bing is probably our most visible and obvious application. But we don't develop all of those individual answers. If you type in, what is $1 in pounds, that's not my team. That's some other team. But we are hosting that component. We're hosting that. So we're the platform for all of those people. And all of those people develop completely independently of us. We're not all sitting in the same room. We don't have shared repos. It's much too large and distributed for that. And so the challenge is, how do you push this new policy, this new way of building across an entire organization? It's not really feasible, or maybe even possible, to just have a day where you say, okay, on April 1st, we're all on .NET Core and it's all just going to magically work. It doesn't work like that. You can't just flip a switch and everybody's transferred and builds. There's a lot of things. So that's one aspect of it. A lot of it was just dependencies. Bing has been around for a while. Microsoft has been around for a long time. There are a lot of components that were built in C++. There were a lot of components that are built in .NET Framework. Sometimes they use specific APIs that aren't supported in .NET. Well, back then it was Core. I'm just going to say Core to be a generic distinguishing differentiator between between the platforms. But there's a lot of stuff. So we have to work through those dependencies, and we kind of have to do it in a bottom-up approach. So, go down to our base level dependencies. What doesn't work? What isn't compatible with the new runtime? Fix those. Find the teams responsible for those. Cajole them, talk to them, beg them, sometimes do the work ourselves. And, you have to repeat this a few dozen times sometimes.
So it's politics as well as technology, right? You're like literally convincing people this is a good idea.
Yeah. And thankfully, there wasn't a whole lot of convincing we had to do. I think the value proposition was fairly clear. And my team has always been pretty aggressive about staying on the forefront because, I'm sure we'll get to this, but, we see a lot of performance gains and feature gains when we do keep up with the latest .NET releases. And so it's very easy for us to sell that story to our leadership and say, hey, this, we get a lot of benefit from staying up with .NET. And by the way, .NET Framework isn't going to be supported forever. So we kind of have to move. Our team has a fairly close relationship with the .NET team. We work together, we debug problems, we find bugs. So we want to maintain that. We're not going to stay on Framework. So this isn't a nice to do, it's a have to do. And then, with our partners, with these thousands of other developers, it was, we just had to be aggressive, and we had leadership support and just said, this is happening. You are going to migrate to .NET Core. We will help you. We will solve whatever problems we can, but you do not have a choice. You either migrate or you get turned off. Mm-hmm. And I don't think we received very much pushback, a few things here and there. And it's like, hey, this is hard for us. It's going to take us a while. And like, yeah, okay, it's hard for us too, but we still have to do it. Mm-hmm. And we're going to push you pretty hard. And, all of that stuff takes time, but it was a fairly, it was a 2-year effort, but it was fairly continuous effort through those 2 years. It was always making progress and solving problems, finding issues. And once you get everything just basically working, then you have to validate performance and make sure that, all the little things still work, all of the edge cases that aren't going to be caught in all of your tests. And so you have to start doing deeper and deeper testing and wider testing and, start flighting things in production a little bit. So little by little, we start getting more and more out there until one day we say, okay, this is it. We're going to deploy.
So to give the audience a sense of scope, I'll quote some numbers that are 2 years old now, but they're public numbers. On each machine, Zap, XAP, Zap is loading over 900,000 workflow instances, 5.3 million plugin instances with a process with 50 gig heap that loads 2,500 unique assemblies and does JITting over 2.1 million methods. I can only assume those numbers are bigger now, but I'm thinking if you're moving to a system like this and you have that many assemblies and that many methods, you're going to want to spend extra careful attention to the jitter, the garbage collector. There's a lot going on.
Yeah. Yeah. Just the scale that we operate at means that we see problems that few other people will see. That's one of the reasons the .NET team loves us, is because we can actually, we can copy some test traffic onto specific machines, and then they can just jump on there and see what does a real world workflow look like? How does it behave? How does the .NET runtime behave under stress? And we have found and fixed all sorts of things through that process.
It's funny when someone will call and they'll say, "Hey, Visual Studio's slow," and I'm like, "Oh, okay, why?" "Well, I've got 10,000 projects loaded." I can only imagine with the .NET, and you're like, "Don't do that." When the .NET team hears gets a phone call from you, and they're like, "Yeah, we have 2,500 assemblies loaded in memory, and we have a 50 gig heap." That's cool, right? I don't know how they react when you call them.
Yeah, I remember having lots of conversations. I want to say at one point we were loading over 6,000 assemblies.
Yeah.
We improved it, but when you have that much code and you want to start taking real user traffic, you don't want that first query to hit your machine and then you're going to spend 5 minutes jitting 1 gigabyte of code that is needed to execute every little piece of that. The user's not going to wait around for 5 minutes, and neither is any other layer of Bing. It's going to give up after a fairly short amount of time. And I remember we would go to the .NET team and say, okay, here's our situation. We have 6,000 assemblies. It takes a few gigabytes of code. If we were to just run NGen all of this, it would take a few hours. We don't want to do that a few times a day. But we want our process to start up in a reasonable amount of time. Right now, it's taking 30 minutes. Can we do it in a lot less time than that? And, at some point, I think they just looked at us like, well, that's kind of crazy. I'm not sure what to do. And then we have other constraints that make it so we can't use some of the cool new features of, AOT compilation and PGO. And, some of those things are pretty sexy, but, there are some other design constraints that we have that limit the effectiveness of that for us. But it is really quite amazing just through, engineering improvements in .NET, improvements on our side, and just new ways to attack things. We reduced our startup time from over 30 minutes down to 3 minutes now. I think under .NET 7. I think as of .NET 6, it was under 3 minutes. Now, most people will say, 3-minute startup time is pretty high. But we are talking about a fairly large process that's loading thousands of assemblies, many gigabytes of data, has to process it, get it ready for query time. So it is doing quite a bit. Most of what it is doing is actually jitting for that 3 minutes. It's just going through the code that we know needs to be jitted and just jit on as many cores as we have.
Well, I know you've been looking at NGen, ready to run images and things like that since 2018. There's a really great blog post by Mukul Sabharwal, who was talking about the move to .NET Core 2. Just that move from Net Framework 4.7.2 to .NET Core at the time, .NET Core 2.1, had a 34% improvement in perf. Just crazy latency improvements. Now you're looking at .NET 7, so you're 5 versions of .NET beyond. Is it just double-digit improvements every time, and you're just getting crazy latency, driving it down to 0?
Yeah, I actually get a little nervous when I bring that up because it's, it makes me look good every time I upgrade us and we do get a double-digit improvement. But it's like, when is this train going to stop? At some point, it's not possible, right? You can't keep improving 10% forever. But so far, a lot of these gains have come to us. From my perspective, they're free. It's not quite as easy as flipping a switch and saying, hey, now we're on .NET 7, but it's not that far from that either. Mm-hmm. And just to get that, it's pretty amazing. But yeah, when we moved from Framework to .NET, we went to 5. When we started migrating, .NET 2 was the target, but it took us a couple years. So by then we were on .NET 5. we saw those 30% perf gains, just from migration. Now that was a lot of effort, 2 years of effort to do that. When we moved from 5 to 6, the improvements were still there, but I think it was still a 5 to 10% improvement in latency. And then, JIT time improved, CPU usage went down. And then from 6 to 7, we kind of saw the same thing. I think 6 to 7 was a little bigger than the transition to 6, where, again, we're seeing 10 to 20% improvement in efficiency. And yeah, that's amazing. I mean, kudos to the .NET team and everybody who contributes to that project.
Yeah.
It's just phenomenal how, just how much more efficient things get.
Yeah, and when we talk about perf, it's important for our friends that are listening who are .NET people and our friends who are listening who are not .NET people. We're not just talking about perf. That's a general term. We mean there's the jitter, there's assembly loading, there's whether you use ready to run or not, there's startup time, there's latency. Like each of these are different opportunities for improvement. And you all, the Bing team, have been really transparent. Like I don't know why I'm surprised, but like you write long technical blog posts with what looks like charts and graphs that you just screenshotted off of some internal dashboard. Is that real?
Yeah, those are real numbers. I am definitely taking out some information. I'm not going to, give internal names. I think absolute latency numbers probably. I don't know if we want to publish those. At least I don't want to make the decision to publish those. But yeah, I think the startup time I did. I did put those numbers out there. Just because, 40% drop, I think.
Yeah. But you show these graphs and then you have like a line and you're like, here's the switchover. So I want to talk about the switchovers and I want to talk about this hybrid model. So let's go hybrid first. So is it true? How does this work? You were building against .NET Framework 4, meaning you're using what? You're using MS Build and using the .NET Framework 4. You're linking against, you're compiling against all stuff, assuming that you're going to run on 4, and then you don't run on 4. You take the IL, you take the assemblies, and then you run them under .NET 5. Why is that useful, and what's going on there?
Yeah, so we conceived of that as a way to bootstrap ourselves. So, since we're a platform, we are producing an SDK for our partners to build against, and they're all still going to be building against .NET 4.7.2 or whatever. And in fact, a lot of them still are. Now we have migrated, I don't know, maybe the majority of people to build against .NET 6 by now, but it's that whole world problem. You can't convert the whole world at once, and so we knew that at some point we were going to have to host .NET 4 assemblies under .NET Core, and thankfully, I think in an early version of .NET Core, I don't know, was it .NET Core 2 or something, they did make it possible so that the .NET Core runtime would load framework binaries and it'll execute it. The IL is all the same. Everything's the same. Now, where it'll get you is if there is an API that is available on .NET Framework that's not in .NET Core. But they had a tool called API Port that could analyze your binaries for all of the APIs you're calling. Now, this tool has been, I think it has been moved into, what is the new name of it? The .NET Upgrade Advisor, I think is what it is now. So it's a bit more comprehensive. I think it'll actually convert your code and projects for you, but it'll also tell you what will break.
Right. We had API Port, and then you had the .NET Portability Analyzer. API Port still on GitHub, and now we have the .NET Upgrade Assistant. So it's just everyone's trying to get folks upgraded in a really easy way.
Exactly. So we use the API Port. And we actually use that in our build pipelines. And so we would start blocking our builds. If somebody, first we have to get to a clean build. So we run it and see, okay, what's broken? Do we need to fix it? Is it in a path that actually is going to get called? Is it obsolete? Is it, you have to figure out what to do with all these things. We stick it in the build pipeline, and that'll block us from making any changes that won't run under .NET Core. And then we did the same thing to our partners. And that was a bigger job. We had some really great devs on our team who put that in the pipelines and just automated it. So when people are making changes to their plugin code, they have to go through our build pipeline to get deployed to the system, and we could just analyze it and say, hey, you're using an API that's not going to be compatible. Like, it works now, but you're on notice. You have to change it. You have to fix it. And we produce documentation like, here are the top 10 things that plugins are using that don't work under .NET Core, and here's what you can do. And I think 9 out of 10 of them were fairly easy to fix. And then one of them was, you're just out of luck and you need to do something else. But we didn't get too many complaints about that. And so that allowed us to at least get to the point where all of the code that was going to be running in production was going to be compatible with .NET Core. And so the next step of that was, okay, well, now we need to actually run this under the .NET frame, the .NET 5 runtime. And so you can have this thing called an application host in .NET Core. And we just built something called a core host process that was built against .NET 5 at the time. And it literally just did reflection. It opened up our main assembly that was built under framework, found the main function, and called execute. Just passed in command line parameters and then just ran it. Just like that. It was literally that simple. It was a 5-line program. But its only purpose was to bootstrap it into the .NET runtime. And so that way we can still build against .NET Framework. We can still ship all of these components that are compatible with .NET Framework to our partners. They can still build their plugins under .NET Framework 4.7.2. We get the compatibility check now so that they can be blocked if they're doing something they aren't allowed to. But then when it actually comes to production, we're not running under framework. We're running under .NET 5. Now that lasted maybe 6 months where we ran in production like that. And then at some point we no longer needed the hybrid. We just started building our whole platform directly on .NET 5. The SDK components, at that point, we had been doing this for a while, but all of the libraries and things that our plugins depend on, that we depend on, we started migrating those to build against Net Standard 2.0. So 2.0 is implemented by both .NET Framework and .NET Core. So it works under both. And so our SDK now consists of pretty much all Net Standard 2.0 binaries. So regardless of where our partners are in the process of migrating to .NET 6 or 7, they can still build. And even if there's some plugin that no longer has an owner or they don't want to update it, it still works.
Mm-hmm. So then before you did the upgrade to .NET 6, you had that system of multi-targeting. You're building against 5, you're building against .NET Framework. I understand that there was some conditional compilation, a little pound define action there. How much if-defing did you have to do? And is that common?
I would say not as much as you might think. It's mostly around the edges. There's some APIs that, especially those related to Windows or the system, for example. You want to get the number of processors or the processor frequency, registry access, things like that. Oh, and then another category is APIs that are more efficient in .NET 6. So they've introduced some new API that just performs better under .NET 6. And we want to take advantage of that. We want to get all the performance we can out of the system, but we still have to produce this Net Standard 2.0 compatible SDK. And so in that case, we might say, okay, well, people are going to build against the Net Standard 2.0 version, but when we actually run in production, we're using this other real version that's going to do something more efficiently than the Net Standard 2.0. And so we have a few places like that, but it's actually not that much code. It's just here and there where we want to, specifically use something. There are also a few odd APIs here and there that work with .NET Framework and they work with .NET 6.0, but they don't work with Net Standard 2.0. And so there's a few instances like that where we will build against both frameworks, but not Net Standard. So just little odd places. But, most of our code is the same across all versions, all targets.
So when you switched from, let's say, 5 to 6, was this kind of like, is there some slider bar and you're like, all right, 1% of Bing is on 6, now 2%, 3%. And there was a time when we were all doing our searching and no one's noticing, and then you're just rolling out. And how long did that rollout take?
Yeah, so it is kind of like that. It's not, maybe slider bar is probably too granular, but, we have multiple data centers across the country, across the world. And then in each data center, we have different groups of machines where we can decide, okay, we split up our rollout into basically as many groups as we want. And that's basically, however many machines we're comfortable with being down at any one time. And we just roll out in those groups. And so, yeah, on rollout day, we have a Canary data center. We have, before it gets to this point, of course, we have lots of test data centers and test machines and things like that. But, when it's actually going into production, yeah, we roll out to one data center at a time. And I think with the .NET rollout, it was such a big change. We were exceptionally careful with it. I usually we give it, a couple days or so just to bake, make sure everything's fine, because no matter how much testing you do, there's nothing like production scale. And so with this, yeah, we're probably pretty slow. This is a few years ago by now that we did this, or at least the transition to 5. When we go to 5 to 6, it was a little bit easier, and it was more like just a standard rollout like we do all the time. But yeah, it's unit by unit in each data center, and then it's data center by data center. And of course, we have different schemes and different ways that we have staged that over the years without getting into too much detail. But yeah, it's definitely all staged little by little. So if you're searching on that rollout day, every search could hit a different machine depending on where you are in the world. It'll hit a different data center, and it may or may not be on .NET Core on that day, or on previous version .NET 5. But if we've done our job right, which we have so far, you wouldn't know. You wouldn't see the difference. Hopefully, it'd be a little faster.
Yeah. So now you're making the upgrade to 7, and I understand that there were 2 major changes in .NET 7. There's how the thread pool operates, and then there was an interesting region-based GC that I think Maoni spoke about on her blog. And that region-based GC, you saw some nearly 30% improvements in the time that processes spent in the GC. Well, why was that something you needed to worry about? Why didn't you just upgrade blindly?
Yeah. So I think actually the .NET team worried about us more. Maybe we have too much implicit trust in them, but it's well earned. But they actually did a lot of testing for us and on our systems with the new region-based GC. They wanted to make sure, like, okay, you've got this huge workload. You're extremely sensitive to performance. We don't want to be the ones responsible for any regressions. And I don't think there were any regressions to begin with, but even after testing and throughout, they made tweaks and changes here and there just to make sure that yes, this is going to perform well on large workloads. We're very focused on lots of metrics, but memory and GC in particular is one you always have to kind of stay on top of. Now, we actually don't spend that much time in GC. If you looked at our performance counters, there's a Windows performance counter. Well, now it's a .NET performance counter, % time in GC. We're in the low single digits for that usually. It's very low. And that's because we've engineered our software to not need GC. We kind of obey the principle that I've kind of been harping on for a few years since we migrated to .NET 10 years ago. Memory you allocate either has to go away in the first garbage collection, so it's Gen 0, or it has to stay around forever. It's basically a pool. It has to be pooled. You don't want objects going from Gen 0, Gen 1 to Gen 2, and then finally being garbage collected, because at our scale, that you're just going to die. You're not going to get the throughput you need. And so we've engineered our software very carefully to obey those principles. And now, if you're going to redesign the GC, well, how many of those assumptions are changing? We've really designed to how the GC actually works, and we want, because we want that performance. And so I think with the region-based GC, it wasn't that we were concerned we would lose performance. It was just like, well, what's going to happen? What is it going to look like? Is it going to be better? Is it going to be the same? Is it going to be slightly worse? Now, since we spend so little time in GC, even if it had become worse, I don't know that would impact things so much. Because we're spending a couple of percentage or lower of our time in GC, a lot of that can just hide behind IO requests and other things that the process has to do, where there's kind of a long pole to the query, a critical path through that query. And a lot of the time, any GC that happens is just going to hide behind that. But still, you want to know. You want to know at the very least so that you can establish a new baseline and know when you do something to screw it up.
Yeah. So as we get towards the end of our chat here, I know that .NET 8 is out in preview. People may think this is a breakneck pace, but you're already thinking about .NET 8 and testing the workflow engine under that, aren't you?
Yeah, absolutely. I had meant to do that this week, actually, but I've just been stuck on a couple of other projects. But yeah, that's kind of next thing on my list. Yeah, we're in preview 2. I think preview 3 will be out fairly soon. Yeah, we're going to get going on it. We want to provide feedback to the .NET team as soon as possible. Like, hey, here's what it's looking like. It's all good. It's all bad. Hey, you broke this, or I have nothing to say. It just looks fine. There's no difference. That's good too. That's another important point is, whenever we do migrate, our expectation is never an improvement. Our expectation is always just baseline, is just keep it the same. Just don't make it worse.
Right. Expect nothing and you'll never be disappointed.
Yeah, exactly. And so, I don't know if I want to say we expect nothing. We expect it to not get worse. And so far it has always gotten better. So hopefully with .NET 8, it'll be the same. And
that's great.
Yeah, we'll see.
Well, Bing is having quite a year, and you and your team are certainly no small part of that, and appreciate you chatting with me today.
Well, thanks for having me on.
We've been chatting with Ben Watson, Principal Software Engineer on the Bing platform, and this has been another episode of Handsomeness, and we'll see you again next week.